Welcome back, folks. I'm excited for a couple reasons today. I got a real green screen, so I think I'm not gonna disappear on you as much. I still have a limit to my webcam. It also means I can sit in my real chair, so my back's not gonna hurt as much. And I know you're happy about that. That'll make me happy. So you're gonna see my high back chair back here. Okay. Oh, I can hold up blue things too. Ready? Check that out. That didn't show up in a past video, so I'm happy about that as well. Okay, the other reason I'm happy is that we're going to start mesh analysis, and we've been talking about how to use the fundamental laws KVL, KCL, and Ohm's law in order to analyze any circuit, but we've been applying them in a haphazard manner, and we want to get them organized. I want you to walk away from this class being comfortable analyzing any circuit. We're focusing on linear circuits, but any circuit using these methods of analysis. We got to take KVL, KCL, and Ohm's law, and we got to get organized and apply them using a plan, so that when you see a circuit that right now might seem complex and intimidating, that you know how to work the steps, work towards the answer without making things too complicated. Okay, small little applications of these laws will get you there. Here's an example from a later video. I'm going to do this one in a later video, but right now it might be a little intimidating. We have a dependent voltage supply. Okay, look at the inside. It's a voltage supply, and there aren't many things that are in series and in parallel that we can combine. So right now, using the tools we have, we can analyze this circuit, but we have to have an organized method to apply those laws to do that. Okay, flying by the seat of your pants, MacGyvering the analysis on this circuit, probably not going to get you there. So we're going to organize things a little. The first step to doing that is knowing our goal. Okay, in this one we want to find V out. Oh, I can't point up that high. We want to find V out. Okay, but how do we find that? And we define that V out, an expression for V out, using some unknowns. Okay, so before we dig into problems like this, I want to take a brief detour and say, okay, how do we use the unknowns to find values in the circuits? Okay, so let's get rid of this one. Maybe get rid of that one. And let me grab, where did it go? There it is. Grab this. Okay, so the unknowns that we're going to find in mesh analysis are mesh currents. So the first thing we need to do is identify the meshes. And I've done that here for you in these kind of, I think that's cyan. I'm not a color guy. That's green. You can't tell. I'm happy about that. Okay, so this kind of light blue, I've defined the mesh currents. Okay, each mesh, okay, so we've talked about meshes before. Here's a mesh, and then I have a mesh up here. Each mesh gets a current assigned, and that current has a direction. My habit is to make them clockwise. I'll work some problems with them counterclockwise. It doesn't matter. You'll see why I do them in clockwise, in the clockwise direction when I teach you the shortcut. And that's how, if you practice this, you'll be able to solve some of these problems in 30 seconds. Right now you're intimidated by them. You don't know how to start. By the end of this, some of these problems you can do in 30 seconds and get them right. That's the most important part. Okay, so these mesh currents, that's what we're trying to solve for. And then if we want to find any value in the circuit, and that's what mesh analysis is going to let us do, we have to be able to find other currents and other voltages in the circuit. So for this example, we're going to start out by looking at the mesh currents I1, I2, and I3, and we're going to write KCL equations to find IA, IB, IC, ID, IE, IF. Okay? They are KCL equations, but it's not necessarily the fastest way to find the expression by writing the KCL equation. I have a series of questions that I walk myself through when I'm looking for a current, an expression for a current, and I'll walk you through those too, and you'll be able to get the right expression quickly, very quickly for each of these currents. Okay, so let's start with IA, and let's see, IA, and I want to know how to express IA in terms of I1, I2, and I3. Okay, so I pick off a node, and it can be as simple as this node right here, and I1 is flowing around the mesh in this direction. Okay, so I have it drawn as a circle, a semicircle here, going in the clockwise direction, but you need to think of it as going around the outside like that. Okay, and as it comes in here, well, it's going in, right? And that's I1. Okay, so I'm going to write the KCL for that node, and maybe I shouldn't say it's equal yet. Let's just say we're writing it for IA. In that node, IA is leaving, and so it's negative, and I1 is entering, so it's positive. And that's all of the currents going in or out of that little node there, and it's equal to 0. Solve for IA, and we find that it's just simply equal to I1. Nice and easy, right? That one's simple. We start you out simple on that one. Okay, we can play the same game for IB. Okay, so let's figure out IB. Now, where should I do this with IB? I think I should probably work it over here, and maybe I should use a different color, huh? Okay, let's go blue. Okay, so IB is leaving the blue node. Okay, so IB is leaving. And then the other currents I want to think of in terms of the mesh currents. So I3 is flowing around the mesh this way. Okay, so as it leaves this, well, it's leaving the node, right? And that's I3. Okay, and I1 is flowing around this way, and we already know that I1 is IA, right? So we know I1 is entering the node. Okay, so IB is leaving, I1 is entering, and IS is leaving, and that's equal to I3. I can't even read my own handwriting. Let's clean that up for you. I3. That's slightly better. God, there's no sources. This is a completely made-up circuit, by the way. There is no source pushing voltage or current, anything like that. Oh, the squares. The squares. There's two different standards for drawing schematics. There's the American standard, and in the American standard, the resistors are those squiggly things that I've been drawing, right? That would be a poorly drawn resistor in the American standard. The European standard resistors are these boxes. Okay, in American textbooks that use the American schematic standard, these little boxes we use to just say it's a component. We don't know what it is, but it's a component. Okay, so if you do go practice in Europe and you see this box and you're looking at a schematic, I had one customer that had some European schematics for us, and you got to know which standard you're working towards. Right now, my intention with these boxes is, hey, they're just some component, and we're finding the currents through them. Sorry for that aside. Back to finding IB. So I1 minus I3, we've got to solve for IB, and we can just pull that over to the right, and then I'm going to flip the sides of the equation. It seems to happen a lot, and I get I1 minus I3. Okay, so I've done these two because I want to convince you that they're KCL equations, because I don't want things to come out of nowhere. I could teach you how to write the expressions. I could say these are the questions to ask, and we're going to get to equivalent expressions. But they are KCL equations because everything in circuit analysis comes out of KVL, KCL, and Ohm's law. Okay, so IB equals I1 minus I3. IA equals I1. Let's work through the questions and get the right answer for IA and IB, and then let's apply it to the rest of them. Okay, so let me scroll down here, and the questions I ask Okay, questions I ask to write these quickly. And when we're in the classroom, or I'm going to try to do it in live sessions, I try to repeat these questions every time I need to write one, so that repetition makes it stick in your head. To write these quickly. Is that behind my head now? Uh-oh. My image isn't big enough. Hold on, I need more paper. Okay, that should be better. Get that up there. Questions I ask to write these quickly. The first question is, as I'm considering whether an individual mesh current is part of the equation, does the mesh current touch the current I'm finding? I usually just say it. Does the mesh current touch it? Touch the current I'm finding. Okay, that's the first thing we do. And then, does it flow in the same or opposite direction? How do you spell opposite? 2T. Okay, I don't know. I don't think that's right, but let's just leave that to spell check. The same or opposite direction. Okay, the first question is going to tell me whether I include that mesh current in the expression or not. The second question is going to tell me whether it's positive or negative. And that's how we do this. Okay, so let's see. If I'm writing the expression for IA, I say, does I1 touch it? Okay, does I1 flow through the arrow for IA? And it does. Okay, so I know I'm going to include it in the expression. Okay, so we can just say IA equals I1. And does it flow in the same or the opposite direction? Okay, I said I1's going this way, and it looks like it goes in the positive direction, so it ends up being positive. Okay, so I know to include that term. I ask myself for all of the mesh currents, even though we can already see that I'm done. I ask myself for all of these mesh currents. Does I2 touch IA? No, it doesn't, right? So I don't include it in the expression. Does I3 touch IA? No, it doesn't, so I don't include it in the expression, and I know I'm done. So if I walk through them that way, I can really quickly write that. Let's do it again for IB, so that you see we end up in the same place, and then let's extend it to the other currents that we're looking for. Okay, so let's see. IB is here. Does I1 touch it? Oh, I'm going to say, well, IB equals, and then say, does I1 touch it? Yep, it does. Okay. Does it flow in the same direction? Yes, it does. Okay, it's going left to right. So it's positive. And then does I2 touch it? Nope. I2 doesn't touch IB. Okay, so it doesn't get included in the expression. And then does I3 touch it? Well, yes, it does, as it comes back around here. And it's flowing in the opposite direction. It's going right to left if I'm moving clockwise. Okay, so it's going to be negative. And look at that. We got the same expression. It's a lot quicker. And if you kind of train your brain to do this, you can write these KCL equations really quickly. So if I know the mesh currents, I can find any current in the circuit. And that's why we really want to have a method of finding the mesh currents. Okay, where do I squeeze everything else in? Because I want to keep these questions for you, but I'd like to get everything on the screen. Can we do it? I can always... Let's do this. I got another copy of the schematic. There we go. Okay, so the rest of them we can do pretty quickly. We can say IC is equal... There's IC, right? I1 doesn't touch it. I2 does, and flows in the opposite direction. Okay, I3 touches it and flows in the same direction. Done. Okay, So not only can you now write the KCLs, but you can write them quickly and you can write them accurately. And that's what we're going for. Okay, ID. Now you see why I don't write in lowercase if I can avoid it. ID. Does I1 touch ID? Nope. Does I2 touch ID? Yes. And it flows in the same direction, right? It's going down as it goes clockwise. So it is positive I2. Does I3 touch ID? Nope. So that's it. We're done. IE. Where's IE? There's IE. Okay. Does I1 touch it? Yep. And it goes in the same direction. So it's positive. Does I2 touch it? Yep. And it goes in the opposite direction, so it's negative. Okay. Does I3 touch it? Nope. So there's no I3 over here. Last one, and then you're experts, right? IF is equal to, let's see, does I1 touch IF? Nope. Does I2 touch IF? Nope. And does I3 touch IF? Yes, and it flows in the positive direction. So it's going to be positive I3. Okay, so if I know the mesh currents, which we don't know how to find yet, but we're working up to that. If I know the mesh currents, I can find any current I want in the circuit, and that's a really powerful thing. Let's end this video here, and in the next video we're going to do the same kind of thing, but we're going to go find any voltage in the circuit. If I can find any current, or if I can find any voltage, then I can figure out anything I want about the circuit. So if I know the mesh currents, I can figure out anything I want about the circuit, and I don't have to work it twice. I can find the mesh currents, and then I can learn whatever I need to, which is pretty stinking handy if you ask me. Okay, so coming up, finding any voltage using mesh currents. And then after that, how do we find the mesh currents? So stay tuned and good luck.